For my game Treasured, I wanted the player to show through objects. So when the player goes behind this rock, for example, he is still visible. I wanted something special, something I had control over, but I couldn't find a good blog or tutorial that would give the results that I wanted. So in this video, I will show you how to get the screen position of the player, how to render a circle, and how to add effects to the circle. So this is the scene that I will be using. It has a light source, it has a camera pointing at the wall, it has a ground plane, and it has a little red capsule behind the wall. So currently, if we go to the game view, we cannot see the red capsule. But if we grab the right shader, we can now see the capsule through the wall. We even have control over the size, but of the smoothness of the edges, and also the opacity of the circle. At the end of the video, I will also show you how you can apply other effects, like noise, to add some flair to the circle. So the first thing that we need to do is create a graph, which you can do by going to Create, Shader, and either you can select the unlit or PBR graph. I have already made a shader graph with a basic texture and tint functionality. And here is the master. Because we want to use the alpha point of the master node, we need to set the surface to transparent. Let's first start by creating an ellipse node. This will essentially be the base, but we will replace it with some code that we'll get into later. So let's first grab the UV, which is the screen UV, so screen position. And because we want to create some offset and tiling, we need to create a tiling and offset node. Let's grab that in UV and put that in UV. So if we put that in the alpha node, you can already see from the little preview that it is inverted. So we need to invert it by going through a -1 function. So you can see that the mask basically changes. Alright, so in Unity, let's quickly create a material. Let's call it see-through. That's great spelling, but doesn't matter. Let's go to Shader Graphs, Circle See-through. So when we apply that to our wall, we can already see that something is happening. It's just not the desired result yet. But because we can see the circle, that's already great. First, we need to get the offset. So how do we get the offset? Well, we can first create a vector2 called player position, which we want to change in code. So we need to set the reference to something that we can use. So let's say _position. It is this position that we can put in offset to create an offset. Although currently it is not really what we want. Currently the center is 0, 0, but if we transform our world position to viewport position, then the center will be 0.5. So we need to remap our player position code to range to have 0.5 to be 0. So let's do that real quick. Let's remap our input from 0.5 to 0.5 and minus 1.5. I know these numbers are a bit weird, but you'll see that it works. Okay, so now let's see 0.5, 0.5, which is not in the center. And that is because we need to add what we have remapped to the screen position. So let's add an add node. Let's first add screen position to the remapped one. When we press save, we can already see in our game view that we have a little ellipse in the center. But it is a little bit stretched. We want it to be an actual circle instead of it being an ellipse. So let's change that in our ellipse width and height section. Let's add a vector one. We call it size. We also want to control this in code, so we need to change the reference to something recognizable. So underscore size. In order for us to actually get the correct width and size, we need to take into account the aspect ratio. So let's grab the camera and a divide node. And to get the aspect ratio, we need to divide the height by the width. We can now multiply this aspect ratio by the size that we have just created. And we can change that, we can add that to our width node. Of course, we also want to supply the size by our height node. And as you can see, we go to our scene view and set our size to 1. We can see that it is now a circle and that we have control over this circle. Great. So let's go back to our shader graph and let's first start to categorize some of this stuff. Alright, we now have a screen UV section and we also have a size correction, which I already took the liberty to add a vector 2 at, which we will get to now. So we have already said that the ellipse node has a edge that is too harsh. So we want to change it to something that is more of a gradient, going from the center to the edge with a little fade instead of having a hard edge, like I said before. So how can we actually grab that, and how did I grab that? Well, if we click on the ellipse node, we right click that is, there is a little section that said show generated code. So let's click that. So this is the generated code for our ellipse node. And we can see that there is a bunch of stuff, and if you are familiar with shaders, with the normal shaders that is, we can already kind of see that we have a vertex and a fragment shader here. But this is not what we're after. We are looking for Ellipse Code, which is this function right here. This function right here, these two lines, will actually give us the correct thing that we want. So let's implement that. In Shader Graph, let's first get rid of the ellipse class, node that is. And let's implement what we see in the two lines of code. We can see that we first have a length, which we will get to later, but we can also see that we need to multiply UV by 2. We know that our screen UV tiling and offset output is our UV, so let's first multiply that by 2. Multiply by 2. Then we can also see that we need to subtract 1. So let's subtract 1. Then it says that we need to divide it by our width and height in a float 2, or a factor 2. So let's get a divide node. put the UV stuff in the top. And this is why I made a vector 2 node in our size correction group, because we can now add that to our divide node. And as you can see, we have now completed all of the different things within that line apart from the length node. So let's add that. And now we can get to the second line. So the second line shows 1 minus d, where d is the first line. So let's 1 minus. Okay, so there might be an issue where you can see these pink squares if you open them up. And this is because our default size is 1, which will then in turn also be the size that is used within the calculations. And it apparently can't do 0. So let's make 1 instead. And we can already see that now this is fixed. Let's also set the player position, the default player position, to 0.5. And now you can see that we have a circle in the center. Alright, so that is basically it for our code, apart from the saturate node. And that is basically all of it done. You can see in our saturate node, we have a nice circle going in the middle to the edge in a gradient, which is just what we want. So if we grab this and put it in our 1 minus function, we can save it. We can now see behind the wall. Great. So the only thing that we want now is a SmoothStep node, where we put this in our in function and we create a vector 1, which we call smoothness, set the default to 0.5 and the mode to slider. So if we set this smoothness in here and we put that in 1 minus, we can now see that we have control over the smoothness of the circle. The only thing that I want to add is the opacity, which we can add by multiplying the SmoothStep, and we can multiply it by a vector 1, which we call opacity. Let's set the default to 1 with a mode to slider. Let's save the asset. And now we can see that if we lower the opacity, there is less see-through. So to recap, we can now change the position in the shader to change the position on screen, which is between 0 and 1, which we can use in code to then control where the player is. So let's now first set some variables for our circle. Great. The only thing now is a piece of code that will make sure that our capsule is always shown at the center of the circle. So let's make a script and call it CircleSync. Let's add it to our capsule and let's open it up in our coding editor. So the first thing that we want to do is delete some of the stuff that we don't need, and let's then add some variables. The first one is a material, since we want the wall material to change. We want a camera, because we want to transform the world position to the viewport position. And we also want a mask because if at some point we want to cast a ray to check if we are behind a wall, we need to have a mask to check the collision masks. We also have some shader IDs, which is the little text that we put in the reference in Shader Graph. And we want to put those in a public static integer. So how do we get it? We can get it by going to shader.property to the ID, and we can input a string. So we have named it _position, and that's how we get the position ID. We can also make one for the size ID, which was _size. Inside our update function, the first thing that we want is to grab the view position from world. So we can do that by going to camera.world to viewport point, and we can simply add the transform.position. In order to supply it to our wall material, we can do wall material.set vector. We can supply our ID, which was pos ID, and we can simply supply view. Like I said before, we want to check if we are behind a wall or in front of a wall. So the first thing that we want is we want the direction towards the camera, which we can get by going to camera transform.position and subtract transform.position. We then want to make a ray going from the transform.position into the dir or direction, but we also want to normalize it. Then if we want to check if we are behind a wall, we can simply go if physics.raycast. We can supply the ray. We can supply some large number that is always going to hit the camera or go behind it, and then supply the mask. Now that we know that we are behind the wall, we can simply go wall material.set float, supply the size ID, and then just say 1. Because when we're behind the object, so if it hits something, then we want the size to be 1. Else, we want the wall material to be 0. And that's all there is to the code. If we now go back to Unity, so the capsule, as you can see, circle sync is there. We have the wall material, which is our see-through material, our main camera, and the mask. Make sure that the layer is also the same for the wall, otherwise it won't work. And now it should work. So there you go. We are in front of the wall and the circle doesn't show, but as soon as we go behind the wall, we can see that the circle appears. Of course, we can add some smoothing to it, so it eases going from a circle to not a circle. But that is all up to you on how you want to add that. We do, however, have a small problem, because if we, for example, show this nice model and we supply our new shader to it, we can see that it has a little issue with the writing to the Z buffer. We can remedy this by actually going a little bit hacky. So for example, if we go to circle see-through and we right click on the master node and we click on show generated code, as you can see, this is the whole shader that is used by the shader graph. And as you can see here, the ZWrite is off and we want it to be on. So what we need to do is we need to select all, so Ctrl A, Ctrl C. Then in Unity, in our folder, we want to create a shader, standard surface shader, and we can call it whatever we want. So let's go see through with the correct spelling, and it will open up. And here is our standard shader. What we can do is we can Control A, Control V it, and now we have copied the generated code into our own shader. Now we can set the ZWrite to on, and we can also, for example, what I did for my own game is give it its own location. So let's go shader, see through. So when we save it and we go back to Unity, and in our see-through shader, let's actually select the one that I've been using. If we now change it to treasured see-through, we can now see, especially in the game view, that the Z issue isn't a problem anymore. You might see a little bit of glitching in the tree line, but I guess we can see through that. I guess that was really Dutch. And I'm not sorry. As a bonus, I also told you that I will show how to add some noise to it, so let's do that. Let's first, in our shader graph, make sure that we have the groups again, so it's easier for us to see what is what. Alright, so how would we add a noise to it, for example? So let's make sure that this is here. Let's add a gradient noise. Let's multiply our SmoothStep with our gradient noise. Then let's add our SmoothStep by what we multiplied. And let's add that to the multiply section. We also want to clamp what we have, because otherwise we'll get some strange artifacts. So let's clamp that. And now we can see that we have some noise added to the cutout. And the noise always stays the same, but if you want to change that, you can easily animate the noise by the world position, or you can either change it by time. That is it for this tutorial. If you liked the tutorial, please leave a like, because it helps me out hugely, and I know that you appreciate these tutorials. If you have questions about some effects that you want to apply, or questions about the tutorial in general, leave them in the comments or go to the Discord server. Links are in the description. So that is it for this video. Bye!